From the Spec Network, this is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm Don Felker.
And I'm Kaushik Gopal.
Welcome to the show. In this episode of Fragmented, Kaushik and I sit down and discuss multi-module builds in Gradle, as well as other Gradle goodies. For example, we discuss why you would want to use different types of modules in a single Android application. Previously, in a different episode of Fragmented, we talked about packaging your application by feature and by layer in the same Android application. But this time it's different. We're actually talking about building different modules inside of the same Android project. This is going to be useful if you have a larger team. Maybe you want to silo different pieces of development into different modules and different teams can work on them and take ownership. You can lower your build times when you have very long build times. And you can also learn different things in this episode, such as how to organize your build.gradle file and also get some autocomplete goodness in there as well. We hope you enjoy. Many thanks to Microsoft for sponsoring this episode to promote App Center. It's a continuous integration, delivery, and feedback suite of cloud services for Android apps that's just going to make you more happier than you could ever be happy. With App Center, you can automate your Android app development lifecycle. You can build, test, distribute, monitor, and push, to ship 5-star higher quality apps faster and with more confidence than ever. Man, that gets me excited. Building a development pipeline for your Android apps has always been a challenge, but with App Center, you can get started in minutes. That's right. Simply connect your GitHub and Bitbucket repos and build right there in the cloud. Test on thousands of real Android devices. I'm talking the real ones. You press your buttons on the clickety-click, the tappity-tap kind. Then you're going to distribute that to beta testers and Google Play, and you can monitor real-world usage with crash and analytics data. As a fully modular suite of services, you can pick and choose the service you need and connect it to the tools you already use. You know that sounds good. Sign up now on appcenter.ms. That's right, sign up now at appcenter.ms and spend less time managing your app lifecycle and more time coding. Clickety-clickety, clackety-clackety. Semicolon. Now forget that, we write Kotlin. No semicolons needed. Thanks, Microsoft. Do yourself a favor. Try App Center. appcenter.ms. All right, Kaushik. I heard it's a little cold over there in San Francisco.
It is. It's uncharacteristically chilly for us here. But I realized that me complaining about it being cold in San Francisco is really not appropriate given that it is way colder. So how cold is it there on your side? It's about 8 degrees Celsius here, which is, let me see, 8 degrees Celsius is about 45 degrees Fahrenheit here, and it's kind of cold for us. How cold is it there?
It's in its high 30s here, but even then it's not bad. And the reason why I say that is when I lived in Minnesota, for all you Minnesota listeners, you'll kind of nod your head in agreement to this, that when it's above 32 degrees there, things are melting. People are outside in shorts and like light long sleeve shirts running around the lakes. You think it's the middle of summer. It's just the wildest thing out there. So yeah, anyway.
Okay, so I should probably not be complaining that it's in the mid 40s here.
No, probably not. But but
we do have those winds though. The winds here are like pretty chilly because they come from the ocean. It's kind of bone chilling.
That does get kind of cold. But on the same topic of complaining, there's one thing I know that we've both complained about a lot, and that's Gradle build times.
That is something we've complained about. Build times is probably our biggest bane, and I guess in today's episode, we thought we'd touch about topics very similar, right?
Yeah, definitely.
It started out basically, I wanted to talk to you about how you organize your Gradle file, like a very tactical sort of thing, right? Where like, what does your dependencies file look like, where you add all the dependencies for your app? It started out with that, but as we got like riffing on the topic a little, we realized there's some other things about modularization that we should probably touch as well. Man, that word is so hard to pronounce. Modularization.
Modularization. You're right. It is
Yeah.
kind of difficult.
I'm going to keep saying, at some point, I'm just going to give up and just for the word. But yeah, listeners should know that that's basically what I mean. So
This is a weird topic to talk about because there's so many different ways that you can like modularize or set up your Gradle build system. And I think we'll have to link the episode, but we previously talked about packaging by feature. So you'd have all of your features in your application, and then you just kind of break it down by your Java package name. But today we're going to talk about going a little bit deeper. Is that what you're thinking too?
Yeah. And that makes perfect sense. In fact, that's a good place to start, right? What do we mean by modularization, right? You want to take a stab at it?
Yeah, I think just at a higher level, I think we'll just kind of rewind for a second of how we can build apps and some of the problems that we're encountering. Some of the things that we've been experiencing as Android developers is just high build times. I can't tell you how many times I've been on Twitter and seen someone complain, hey, 18-minute build time or 16-minute build time. And it's funny because I see folks out there in the JavaScript community complain about NPM, and NPM takes, a minute or two. And I'm sure there's extreme examples where I'm sure NPM takes a lot longer. But they complain, this takes forever. And I sit there shake my head. I'm like, you have not even dealt with Gradle. You have no idea what you're talking about. Long time. So what we're basically getting at is your application starts growing. You have a lot more files. You have a lot more features inside of your application. And we're talking directly about inside the application, the app folder of a default Android application. Let's say you have just a couple features. You start building it. It builds pretty quickly. But as things start to balloon, you got hundreds and hundreds of files in there. It's 70, 100 different screens. All of a sudden you realize making one small change turns into a 15-minute build time for some crazy reason. And that's kind of the real problem that we're talking about, is how do we maybe modularize it to make things a little bit faster. And some recent changes in Gradle 3.0 have come out to help kind of speed that stuff up.
Yeah, and I guess that's the kickoff point, right? Up until this point, you're totally right. Like we really didn't have too much that we could do because Gradle was inherently what was limiting in the build times, right? And I do know we have talked to like some other developers at other bigger companies where they explored using a different build system like Buck. We have an episode on Buck that we talked to Gautam about. And that was like a solution where like they've hit a sort of ceiling, so to speak, with Gradle. So they explored other build systems that were better. And primarily the concept that sort of caught everyone's eyes is doing better incremental compilation, right? And I think it was with Gradle 3, we'll add a link to the show notes. With Gradle 3, what happened essentially is that incremental compilation took a step forward, right? And I guess that's the one that's the feature, so to speak, that basically unlocked some of these build time benefits that we can get.
This is one of those topics that's hard to break down because it's a complete paradigm shift. We're not just naturally going from, hey, we're going to kind of move from package by layer to package by feature and we're all in the same app. Well, no, we're making a completely different fundamental change to how we're developing software inside of Android. And that's the key thing to think about here. I'm sure we've probably lost a good portion of people just talking about this. So let's rewind and let's actually discuss about actually breaking an app down into modularizing an app. So, Kaushik, let's just take it from our previous example, which is our episode number 91, where we talk about packaging by feature. That is, everything's inside the app directory. Inside of there, we have the Java packages, and it's, hey, this is the login feature, this is the customer service feature, this is the, the purchase or the bill pay feature or whatever. If we wanted to break that apart into modules, what we'd actually end up doing is actually taking that code that's inside of there that's related to login, and we'd actually create a new module in our application. So that would be inside of Android Studio. You'd add a new module to your project, and that would be maybe an Android module if it was Android related, or if it just had Java code in it, you can make it a Java module or Kotlin, whatever. We create that new module, and that's called our login module, and that's where all of our code for that module is going to go. And we can start doing that repeatedly for all of our different features and so forth. And that starts breaking apart this huge monolith, as you said before, into smaller, manageable chunks of code that are modularized. So we can take advantage of some of the features inside of Gradle 3.0, which helps with the build performance.
Right. There's some interesting follow-up questions I want to ask you because I know you've dealt with this in the past as well, right? Now we talk about like packaging by feature and packaging by layer, and I think it was the episode with Christina where we sort of like also touched on this with her, right? How do you approach breaking your features in the app? It's pretty clear cut when you lay it down like that, saying, okay, there's like the user customer service module, there's the login module, that makes sense. But there are some things that we use in a common way, right? For example, data persistence with Room data. Like say I'm using Room or I'm using Realm. I have databases, right? Independent databases. Do I put all that in a core module? Then there's like the design components. Do I put that in the core module? What about my networking layer? I'm pretty much going to be using retrofit throughout the app, right? Does that go into this module? Like, have you dealt with some of that stuff?
Yeah, I have. And so I'm going to preface this with credit, just paying where credit is due, and a lot of that credit is due to Philip Breault and Michael Bailey, who we've also had both of them on the show here. I learned a lot of the feature,
both super smart chaps.
Feature and module composition from these folks, and they've done a fantastic job. I've worked with them a little bit on some of the stuff. But in short, I think I can't even say in short because it's going to be a long form answer.
I was like, oh, in short, I'd love to hear that.
Well, no, there's so many questions to be answered there, so let's try to handle it. It's the best way to reply to this is it really depends. And so here's why I'm saying this, because there may be certain instances where you're working with a Room database and you're working with an API call, and that Room database and API call may need to be in the exact same location, because you may need to say, hey, pull locally when we're working on on an offline connection, or hey, otherwise connect to the web, or automatically download and cache. So there's a bunch of different things that you have to think about. But so let's take it back even in further. Say, hey, if I do have this application and it is going to require a network interaction, a lot of times I'll put that network code directly in its own module itself. So that's where I want to go ahead and expose all of the networking code in there. And that's going to, return my observables if I'm using RxJava. It's going to return some models. Now, speaking of any types of models that I might have, which might be just the general data models, I might actually put those in their own module too. If those are all cross-cutting concerns, meaning they could go across different modules, I'd possibly put those into their own module as well. Again, this could vary by your project. It really depends on how you've architected it. Some folks, when we start talking about databases in general, are going to say, hey, you should put your databases inside of a core module, and that's where you're going to put it. Now, if you read something else on the internet, someone's going to say, well, actually, you should actually put your database inside of each feature module, so you should have a Room database by each feature. That, to me, feels really wrong, and that's...
Oh, really?
And the reason why I say that is because if we're working with any type of relational data, now I have different databases across different features and different database files because we can't share the same file, or not easily that I know of.
No, that's right. Oh, yeah. There's like some gold in a lot of those things you mentioned, right? For example, and this is like the sort of thing that I was alluding to, but I am curious because I think we have maybe a little different like opinions here, right? And that's fine. That this is like, there's no right or wrong. It's just like an opinion, right? So you mentioned this thing and you're totally right here. I'm a big fan of like packaging by feature, like almost to a fault, where I'm like, no, this is my user stuff, so it should belong in the user module. I don't care if it's a database, I don't care if it's a network. Like these are all sort of what's the word I'm looking for? These are byproducts of what the feature stands for, and so it should be in a feature module. One big problem with that is if you're going so gung-ho with that idea, if you take, for example, and I know this, I can say with 90% certainty this is the case with Room at least. If you use Room, you're not going to be able to have like a shared Room sort of repository across multiple feature modules, right? You'll have to create independent database files. And so for all practical purposes, they function as independent databases. So you'll have multiple databases that you'll probably have to spin up. Again, this might be changing. They might be working on it. But if I remember right, this is exactly the approach that is even suggested by them. Like, I don't think there's another way to go, right? I usually am fine with that. But you're right. It does sound kind of weird when you have your application, by virtue of just having been modularized, comes with now 4 databases. Like, it sounds kind of...
Like, using that, sounds riff on that for a little bit.
So I'll give you that.
Let's say we have that user database and you have another module that's for orders, right? and that order is associated to a user. How do you make that connection when they're in two different databases and perform proper queries that may need to happen?
If there's like right now in the world of web, there's like this whole thing about like microservices going on, right? Like, so each thing stands for like an independent service. And I sort of think of it like that. So let's take the example. Let's like leave the definitions back and take the example you mentioned. It's a great example. If I had, say, a user and I needed, and like, this is a relational database, so I need to connect it to like the orders from the user. You're going to cringe when I tell you this, but basically the idea would be to use like these independent sort of like repositories. You might have a dependency between the two, and that's fine. You can have dependencies between modules, but what would happen is you would probably have to hit one database, pull the data, and then like, maybe send that data across through some means through that dependency. Now, again, there's so many caveats, and like you're right in like asking me this question, like how much data do you send? Ideally, you can just send the minimal amount of information, right? But then if you have to pull it, it has to spin up the other database. So do you store it in the other database as well? There's so many questions, and which is why like the answer you said initially, it depends, makes sense, right? But the idea is essentially you have to pass that data across the wire, so to speak, right? When you establish that dependency, which you're right. It can get really nasty. But at that point, then I would have to think, if these were two independent apps and they were connecting through like a REST protocol or something, maybe deep, and like in our world, we would deep link into like that portion of the app. Maybe you need to store, if you're starting to require a lot of the information from the user as you pull the list of orders, maybe it's time then push some of that information into the orders module, so to speak, right? Again, like this, it isn't a very clean sounding solution, but I think eventually if your app becomes big enough, that's the way to go. Just think of them as independent small applications. I have to mention this with a huge caveat that this is for big applications. Like if you're doing all of...
Let's define big. What's a big?
That's a great question.
Should we think about this in sort of, you could look at it different ways, I'm thinking here, and sorry to interrupt, but I'm thinking maybe we could think of it as team size is big. We could think of the number of screens is big, the number of features is big, because I know that there's, the companies like Uber, they have hundreds and hundreds of engineers that are working on one app, and they're like, a lot of people think like, well, hey, it's just a, and Uber is just an app where I request a ride share. Like, what's so complicated about it? But what you don't notice are all the features that you never see because of certain characteristics, countries, legal regulations, all different types of things. In those situations, that's going to be a humongous app,
Oh yeah, for sure. Yeah, you're right. I have an instinctive understanding of what would be a big application, but you're right. Maybe an easier way to think about it is how many people are working on it too, right? If you have like 15 or 20 developers working on it, at that point, I would say you're getting into a big app territory, right? It's the same thing. Like people, I kid you not, like, you mentioned that question as sort of a rhetorical question, like, oh, what's there in like a taxi app, right? I've been asked that. I was like, well, you work at Instacart. It just delivers groceries, right? Like how complicated could it be? Why do you need more than like 5 developers for this thing? And I'm like, oh, if only you knew. It's not easy at all. They're like very interesting challenges. They're like really complicated things. And a lot of that, if it isn't necessarily surfaced in the app, I would say that's a success, right? Like you don't want people to see the complexity, but trust me, there's a lot of complexity. 2-3 developers will not be able to build this app on their own.
Yeah, exactly. I think the key saying is it's difficult to make something simple. And that's kind of what we're really saying here at a high level. And I can't tell you how many apps that I've worked on that have been, you use this free application, you download it, it's great. But if you sign in and upgrade to pay for the upgrade experience, through a monthly fee or whatever, then all of a sudden you have all these new features that were never there before. And being able to manage that appropriately does get really complicated. So yeah, like you said, if it becomes a big app, it becomes a lot to manage. You have many different features, you have many different things that are happening. It might be a time to think about modularizing. I think where we have some dichotomy or, disjoint in some of what we think how should be done is definitely going to be around some of the persistent stuff, because you think that it would be good to break it apart and perhaps silo each thing into its own little area. And at the same time, I'm probably more on the fence of a monolith. And that's kind of, a lot of folks might be shocked at that, but I feel at some point breaking things into microservices, and I'm talking about the web components here, gets to be like just too much. Like
way
I knew
too complicated. Oh, for sure. And that is the biggest ding, right? Like they say, oh my God, at this point, like I'm communicating, I don't know where this thing starts. Who owns this feature? Does this service own this feature? Does the other service own? You can get into a big, hairy mess with that.
Yeah. And I think there's a lot of folks are probably listening to this who don't run big apps, who are just one single developer, few developers themselves, maybe a consulting shop or whatever agency, are listening being like, why would I ever do this? This sounds so complicated to do. And I think this, like you said before, it should come with a caveat of, all right, you're running into some significant build problems. You're running into some problems where you need to figure out how to get this build under 10 minutes. I mean, and 10 minutes is still a long time. I've seen companies where their build time is over 40 minutes, and it's just insane.
I mean, that's perfectly right. And this isn't an exaggeration. When you say over 10 minutes, I've heard anecdotal stories of people who have had build times of even like Gautam when he came on the Buck episode, right? I don't recall the exact numbers, but they have hundreds of modules, right? And their build time is about 20-ish minutes. And I've heard many other big apps, the big social media services that you can think of, all of them have told me some of their build times are ridiculous, and that's because the app is a ginormous app, right? And I thought that was a great segue that you said, right? Why at some point you realize you need this. This isn't something that people do just for the joy of cleanliness. This almost arises from a need, right? So what are the benefits, so to speak, that we get from this?
I'm going to hop in there and just jump back a few seconds and prefix this with saying, if you had an application and it's working fine and you said, hey, well, let's just go ahead and break this into modules, and hey, Don, we want you to turn this app into modules. I'm not really going to want to do it. It's not something that's super fun to go do.
You're not super stoked by the idea of modularizing someone else's app?
Modularizing anyone's app, my own app, it's there's got to be a big enough reason for me to want to do it, because otherwise, it's a big, significant chunk of effort. You got to make sure you're planning it properly, because let's say you move all of your, let's say you move everything in independent databases and then realize wow, that was a bad decision for reason X, Y, or Z.
Oh boy.
Now we're going to go undo all of that, or now we have to completely reorganize. That's not just a quick trip down the, memory lane. That's a significant engineering effort that's taking away from product development time.
Absolutely. You have to be able to justify this. If you don't, then you probably don't need it,
Yeah, definitely. But you did mention what are the benefits that we're going to get here? I think the biggest benefit that you're going to get here is being able to have this incremental compilation, which is coming with Gradle 3.0, and they introduced some of the new methods in your build.gradle file to say, hey, this one is actually going to be I'm just going to rewind here. Before, we would build a build.gradle file, and inside of it would say, hey, we're going to have a compile dependency, we're going to have a provided dependency, we're going to have something else like that. And some of those things have now changed to be implementation or API, and a lot of this is kind of old news to a lot of folks, but some folks haven't understood it and know it. But basically, depending upon the type of configuration that you choose inside of your build.gradle file will then determine if that implementation is exposed to its parent or any higher level components that are going to be using that component, which then in turn can affect your build times in general. But to kind of put a bow on that whole thing, the big benefit that I'm seeing here is build times and organization. What about you?
Actually, reminds me, you asked the question, how do you define what is big? Well, if you start to see your build times go insanely crazy, that's a good indicator that you're probably hitting that spot, right?
Yeah.
Incremental compilation for sure. And we'll make sure to add a link to that guide. You're right, it came back sometime. I think Gradle 3.0 is some time back. But we'll add a link there that explains some of those differences between API implementation and the new APIs. It's done really well, so I don't think it makes sense for us to go through it again. You said code organization, and this is a point I wanted to bring because actually at Instacart, we did hit a sort of requirement where it made sense to start modularizing based on ownership. So this was something that we're exploring, and I think this is the route that we're going to go. But let me give you a quick background as to why I think this is important. So this is by virtue of the way we operate. Like, for example, at least on the back end side, like where we build the apps for shoppers at Instacart, right? We have a very tight PagerDuty schedule. For those who don't know, PagerDuty basically is this idea that if something is going wrong, an engineer is paged immediately. And you decide to be on call, so to speak, for a certain number of days, right? Now, where it got complicated for us is essentially we have our service has grown to a point where we have different teams owning different parts of the service, right? Ideally, what we would like is a team takes care of that part of the service. The problem is the team has like 3 mobile engineers all working on the same monolithic Android app, right? That's where it got complicated. And we're like, essentially what will happen now is we have a very automated system. So essentially, if we have a problem, Rollbar, who's, full disclosure, is a sponsor, but we love the service. I swear by Rollbar, like even at the mobile layer, right? So what typically happens is the client, if it starts to see that a shopper is stuck for some reason, or there's like some error that's really like nuking the hell out of the shopper, immediately that shoots a rollbar. And then we have a PagerDuty, which is another service that sees the amount of rollbars. And if it crosses a certain threshold, immediately one of us is paged, right? Now, the question is, if it's a monolithic app, who do we page? Do we page person from team 1, from team 2, or team 3, right? Ideally, you would want to page the person who worked on the feature, which means the engineer who is on that team, right? The problem, though, is like when you have a monolithic Android app, how do you differentiate between the two? How do you differentiate between like each teams? You need some way to sort of identify that this part of the code belongs to like this team, or belong is a kind of a strong word because like really all the code belongs to all of us. But who owns this part of the code, right? Who's responsible for this part of the code? And I figured like if you modularize your app, it actually makes it really easy. Now, you don't need to necessarily modularize. You could put it into independent packages, and that's maybe a start to solve my specific problem. But this coupled with some of the other benefits that we get with modularization is essentially why I've started to like explore this as like probably a real and viable option. So
what are some of the other the benefits that you're seeing from modularization?
Well, ownership is a huge thing. The other thing is also it basically boils down to just these two: incremental compilation and ownership, right? Now, the thing that made the mix recently is where Google announced the feature for Android called Instant Apps, right? And we've had an episode with Zara on this, episode 90, I think. We'll add a link to the show notes. Instant Apps is kind of a pretty cool feature. If your use case serves it, Instant App is an amazing feature. And one of the huge prerequisites of Instant Apps is that everything needs to be modularized, right? In fact, with Instant Apps, they take it a step further and they say like each module or each small independent app cannot exceed 4 MB or something, right? Which is kind of ridiculous if you think about it, if you think about the size of the app together. But that is a huge constraint that's put in, right? So this is like another benefit. If one day we wanted to be able to split our app to serve as like an instant app, the instant app feature is very compelling. It basically, the amount of drop off with the users as they begin to use your app could significantly reduce if, we have like this instant app sort of a flow. So that's another reason why I think maybe it's important to keep an eye on it, because in the long run, this might serve as a very important feature. So that's the ones that I could come up. Do you think I'm missing anything, or do you think there's something else we should probably add in?
No, I think that's probably the big ones. And I think it's important to note the reason why it works with instant apps better is folks may be wondering, like, what does it matter if it's modularized? Well, it's because if your feature that maybe, let's use for example, let's use an online shopping store for an example, and you want to provide that feature as an instant app, you may need a couple of things. You're probably going to need your network stack, and you're probably going to need some views around a couple of key screens. And at that point in time, if you want to install the instant app, you don't need the rest of your application, which includes a ton of other stuff. If you've modularized it properly, and you've maybe only using a network module, and you're using your perhaps your shopping module that just has, a shopping cart module or something like that. At that point in time, you can then compile your little instant app based upon those two things, and you're not using all the rest of your app. It's just easier to set up that modularization. As if it were a monolithic Android app, then you basically have one huge APK that's just not going to work out for instant apps.
Yeah, I mean, and a very common example is like maybe you have just like a checkout module with like the payment information, right? You don't need that to begin with. Like, what if the user never gets to a point of actually like, placing that order? You don't need to like pull like all of those things. So that's a good example.
Yeah, I think Zara even brought this up with her company. If not, we heard it from somewhere else, I forget. But it's like in the real estate industry. If you are looking at a property online and for some reason you can kind of like deep link into like some type of instant app experience where you get that nice swiping and everything loads for you because if you ever looked at real estate on a phone, the apps, the web apps, they're okay. I mean, they get the job done.
Okay is being very kind, but yeah.
But if you actually use the actual phone apps, the experience is just stellar. And so being able to provide that experience out of the box is much, much better. Now, you're going down this path right now, right, of exploring the modularization, or you've already started it. What would you recommend kind of being some of the steps that you would go through from taking your app from where it is now and modularizing it? What would you do?
So I guess the question is like, where would I start, right? Where do I think I'm going to start? So a couple of things, right? And I think we like maybe Christina mentioned this as well, but essentially, at least, this is what I'm thinking, right? Like there are some things where it's easy enough for me to sort of start out as a module, right? I'm not entirely sure if this is the way to go, but I'm going to like start off by doing some of these things like shared views, for example, right? As part of like, maybe like our designers have like a certain like idea of how like certain components in the app are supposed to work. And by components, I mean views, right? Like, we have like a cart view, we have like our list views, we have like this button that does like it's supposed to look this way. Those are easy enough where I don't necessarily there's no network dependency necessarily, there's no like database dependency. A lot of this is just a shell, right? So that's where I would start. I would start by creating that. But importantly, I think the reason to start with something as simple as that is because it'll also like force you to rethink how some of your files are structured, right? And this is what spurred some of like the ideas for this episode. I was looking at our build.gradle file, right? So before that, Don, the build.gradle file, right? Do you have opinions on how our build.gradle file is supposed to be? Like, where do you store, like, do you have variables? Do you have properties? Like, what are your opinions on how those are supposed to be structured?
I have an opinion that your versions should be centralized in like a versions.gradle file, or some people call them dependencies.gradle or whatever.
Yeah.
And then you should put them in there, and then you can also take that step further where you actually have all of your dependencies in one file, and then you import kind of the dependency in each child build.gradle file as well. It basically makes it so you have one place to make the changes. So just in case if you are, let's say you're using Dagger, right? And you're using Dagger in 20 different modules, and you need to upgrade Dagger. You don't want to go change it in 20 different build.gradle files. You want to go to one file and it just updates everywhere.
The examples you mentioned make sense, like Dagger and like maybe Retrofit or RxJava. You want to make sure you're using the same version.
Yep.
But it can really bite you in the behind with support libraries, right?
Yep, totally.
And I think they have a lint error now. I don't recall, but I've run into this problem where there was some stupid library that pulled a different version of the support library, and by different version, this was like this was a minor version. This wasn't like necessarily like a major version, right? So strictly speaking, they shouldn't have been breaking APIs, but something stopped working, and it was the most bizarrest experience, right? Because you would expect something to work, but it wouldn't, and you wouldn't even know why, because like you would look at your dependencies and you're like, well, I think I'm importing this support library, right? So that's one huge benefit where like if you standardize the dependencies, you're supposed to be expecting this, and then like you can maybe run your dependencies trees.
Again, you can do this many different ways. So let's take the simple example. You have 10 different modules, right? You want to make sure you're all on the same exact version. And so what you can use is you can use the Gradle ext properties, and then you can actually pull those out into like an ext kind of block looking thing. And we'll provide a couple of links in the show notes showing you how to do this. And actually, Sam Edwards, a fellow Android GDE, actually has a good blog post on how to pull out these dependencies into a Gradle ext type project. And then at that point, you can put all of your versions and stuff directly into just one file. And then at that point, you can just reference those version numbers. Now, the thing is, you may actually have RX Java, 2 dot whatever, and you may have that same dependency listed in 10 different places, but then you're just using the version, basically like a variable inside of your build.gradle file.
That's exactly it. I was gonna ask that. Basically, because Gradle runs on Groovy, and Groovy is a programming language, not like a static XML. You can run. I mean, essentially, I think the approach, it almost seems like a hack, but it's a really clever hack. And we'll add examples. It's like the one that I actually haven't seen, like Sam's post. I should like go through that as well. But the one that caught my eye was like, I think the Google samples. Was it the architecture samples? The Google samples GitHub repository, right? They use a very similar thing. They call it versions.gradle. We'll add a link to that. I like calling it dependencies, but I don't know why. I'm not sure why.
I've used both. Yeah.
Yeah. But essentially, it boils down to that, right? Like it's a bunch of variables. You're declaring these dependencies, and if folks look at it, it'll be more clear. You just declare a bunch of variables in here, and then in your actual Gradle file, you use that variable, right? So it's almost like programming where I use a variable and I reference the variable everywhere else. So it's always just the same reference.
Exactly. And I think, so let's say that you're using it's like implementation and it's com.android.support annotations, and you have the version number. And that's kind of a common one that we see for support library or appcompat v7. Let's use that one. Then if you're using the ext properties, it's just another file. We'll call it, just go with versions.gradle, like you said. Inside of there, you'll have like a versions block, and you call it support lib, and you put 27.0.2 is the value. Then inside of your Gradle file, you can actually then just say, hey, we're going to do but you'll still have implementation com.support appcompat v7, and then where your version number would normally be, you're going to just do a little string interpolation there with the $sign curly bracket, and you'll put versions.support lib, and then it would actually basically take that 27.02.02 and plug it anywhere in where it says version.support lib.
So that's what I used to do. Yeah.
Yep. And then you can go a step further, and this may be, I think, what you're doing here is you can actually create another block off of that, which is just, you call it like libs or dependencies or whatever inside of your ext or your versions Gradle, and I think you're calling it dependencies.gradle, and actually put a variable there and just call it, support appcompat v7, and then in quotes, you would put the full package name and dependency names would be com.android support appcompat v7, and then you could then use another string interpolation there to pull in the version number. And then this is getting kind of really into the weeds, but then finally down in your app or your module or wherever you're going to use that, you'd actually just say implementation, and you would call it, libs or dependencies, whatever you've called that variable, libs.support appcompat v7. And so you're actually just pulling that in directly from that versions file, and you don't actually even have any of the package naming, anything else in any of the child build.gradle files. Is that kind of what you're doing?
Oh yeah, that's exactly it. You described it perfectly. We started out with the version number, and now what we're doing is we're pulling even the declaration into that variable, and we're just using that. So it looks really nice and clean. Aesthetically, it is very pleasing, but there is like actual benefits to doing it this way.
Let me ask you this. Have you done anything with autocomplete inside of build.gradle files?
I think I know where you're getting with this, but I haven't actually done. But can you tell us, what do you mean by autocomplete Gradle files?
So when you're in your build.gradle file, a lot of the times, especially using the method we just talked about, so if you have your dependencies or your libs and you want to pull that into an additional module, a lot of times you don't get until, kind of code complete directly, autocomplete inside of your build.gradle file,
Gotcha. Yeah.
So you'll type something, I want to use my dependencies.retrofit or whatever in my new module I've created. Well, I don't get any code complete at all. And so there's actually a way that you can do that and actually do it with Kotlin, which is actually pretty cool. So you can actually create inside of your, you create a build source folder inside of your inside of your project. And that's going to be basically a build.gradle file. You put a build.gradle.kts file, which is a Kotlin file. And then you just basically add a plugin to that file, which is the Kotlin DSL plugin. And then inside of there, you can actually just start defining variables in Kotlin in a dependencies.kt file and actually list them out. And then inside of your build.gradle file, again, since this is all they're all basically Gradle plugins. It's all going to compile down to the JVM, Groovy, Kotlin, all that kind of stuff. You can actually get code complete. I keep wanting to call it IntelliSense, but that's a Microsoft thing. Code complete inside of your Gradle files, because it's actually using Kotlin under the hood with the Kotlin DSL. So there's actually a blog post. This is the same blog post I was talking about earlier by Sam Edwards. He kind of walks you through that whole process in the blog post.
Oh, so this is amazing. Okay, I'm going to read that blog post too.
Yeah, so it's he's got a bunch of cool little GIFs showing you how it works there, and he's got a couple of videos you can watch and stuff like that too.
Awesome. So stepping back just a little, you also asked me how to create the module, right? How do I start? This is one interesting thing. And initially I noticed you mentioned this, and this is how you know if someone's like in an old school Android developer. You said, when you create the new module, you create the Android module, you create a Java module, right? And this is exactly what I would have said. But as we were looking into this episode, I looked into the documentation, and I realized now, and I wanted to try it out. If you open up Android Studio, the whole wizard thing, and you say new module now, the new module wizard actually presents multiple options.
Oh, really?
I'll tell you some of the options. It's like feature module. There's Android library.
Oh, yes, I've seen that.
There's
Library
Java library, I think it's Java library. But there are like 3 or 4 options now. And so my question was, I don't understand the differences between these things. Because in the early days, the wizard didn't work that well. So I had to do all of this by hand. And I just got used to doing it by, creating the folder, adding the Gradle files, which is kind of barbaric now that you think about it. But yeah, the funny, and this is a trivia question for the listeners. There's a feature module, and there's, let's iron out the easy part. The Java library or the Java module, whatever it's called, is easy because that's basically you have no Android dependencies. It's only the Java stuff, right?
Yep.
And in the early days, this is how you would get super fast unit testing. You would avoid all the Android stuff. You would create this Java module. I remember the early days. I actually went to Xavi. I went to Xavi, and I don't think even he remembers this, but he basically suggested this to me, and I was a big proponent of this henceforth. But that one's easy. Pure Java stuff that goes into the Java library. But there's this thing called, so the next question is, okay, if I wanted Android stuff, but I wanted it to be an independent module, what do I choose? Do I choose a feature module, or do I choose an Android library, right? Do you know the answer to this one?
I'm gonna go with, and this is off my experience working with it. I think the feature is going to be a feature for your Android application, so it's gonna be an actual module inside of your app, and then a library is gonna be something like you're gonna publish an AAR to Bintray or something. Am I correct or wrong?
That's what you would think, and that's exactly what I thought, right? The difference, at least from what I can understand, is feature module is very instant app specific. So this is an instant app Android library, so to speak. If you have a module,
that's kind of a fail on that design.
Yeah, because it's such a generic name, right? You'd think, that's what it is. So if you are specifically building for instant apps, then you want to choose a feature module. And then if you're building it for an Android, if you're building it as a generic module, like what you and I have been talking about so long, Android library is typically what you want to go with. If it actually has Android stuff.
I guess I'm confused. What's the difference then?
Yeah, so that's exactly my next question. I was like, wait, what exactly? Is this just a naming thing that they made it easy so that people who use the wizard understand what to look at? It actually is a little more different because like we said with instant apps, those I'm going to call the appropriate names, feature modules, in quotes. Those feature modules work a little differently, right? They have restrictions where there's
that's
4
right.
MB limit. And if you listen to the episode with Zara, she also said there are some restrictions too. I don't think you can do everything that you do in an Android library in a feature module.
Yeah.
I don't know if those are enforced at this level. I don't think the IDE enforces that. But the biggest difference, at least the most, the visible difference is when you go to your Gradle file, you know how you have the apply plugin thing? You have apply plugin com.android.library.
Yeah.
For feature modules, it's actually different. It's not com.android.library. It's com.android.feature. I only noticed this because I haven't actually worked hands-on with an instant app.
This makes sense.
Yeah, so it is a little different. So you want to pick the right one. I don't think it's interchangeable, at least from what I can tell.
No, this makes sense now that I think about it, because a feature in an instant app, being that you're limited to 4 megabytes, you're actually just launching into a particular feature. And a feature at that point is now considered an entry point into your application. So this is kind of like a a static main void type of scenario here, where this is just for this feature, this is the entry point shell into that. And at that point, you're going to hook into your other Android modules that are going to provide the actual feature and maybe your network stack or whatever like that. So that makes sense. It's unfortunate naming, though, because it is confusing, especially when instant apps are promoted as often as they are. Yet, from a developer perspective, if I want to create an instant app, it's not too obvious where I need to go. But hopefully this helps somebody.
Yeah, I've been thinking a lot about that because like naming is such an important thing, right? And I was like, oh, maybe the direction that Google is probably trying to go with some of this is like, well, if you're starting out as a new developer and this is the first thing that you learn, maybe you want to start off with these conventions because then it's like really zeroed in, But you're right, like some of these things, for example, when I saw a feature module, that made no sense to me, right? But oh well, now we know. So at this point, we've been talking about the benefits potentially of why you would modularize why, and like how you would go about it. But like everything's not rosy, right? Like if this was such if this was such a star-spangled awesome thing, like why doesn't everyone do this, right? So can you maybe like touch on like some of the few caveats, like the things that we have to worry about, or why do like most experienced developers don't readily or wholeheartedly jump into the concept of like creating modularized apps to begin with from the get-go?
I think we can relate this directly back to the web as well. It's just one of those things. If you don't need it, then there's no need to do it. I think, and I know from experience that you can really overcomplicate and over-engineer the heck out of your app for absolutely zero reason other than hearing about it on a podcast. And we are not advocating that you go do this immediately.
No.
We're just kind of promoting the idea that this is out there. If you are running into build problems, you are running into scaling issues within your Android app, because there are a lot of apps that have been around for 10 years now. This is something you may want to look at. But if you're starting out in your application and you work fine, this probably isn't something to do right out of the box. The same thing can be said for libraries such as like Dagger. Just because you can do dependency injection doesn't mean you need to inject every single thing that you can inject. You should inject. That's just also going to slow down your build times too, because it's got to generate code. So as with any tool, it can be abused. And I think this is one of those things that you just kind of have to approach and say, all right, is this something we need to do? And if it is, you most likely have a team with you. And you probably need to sit down with the team and say, hey, look, here's what I've learned. Let's do maybe a little proof of concept. Does this help improve any of our build times? And kind of explore it manually. So that's kind of the biggest caveat that I've seen. What are some of the caveats or a caveat that you've run into?
Oh, wow. But before that, I just want to acknowledge how good a point that is. You hit it on, like, you hit the nail right on the spot. This is, oh God, you can really, I'm not even sure that this process that I'm starting is going to be the way to go, or like, if it's going to work out for us. But I mean, I feel the need is strong enough, at least in my case. But man, you can really go wrong. You can complicate the heck out of things unnecessarily, which is always like the biggest no-no in terms of good software engineering, right?
Yeah, because at that point, there's so much context switching that has to go on, especially if you've pulled out the network layer and the models. You got 10 different things all over the place. And you're like, well, where is this file? Right. You're like, oh, it's over in this module. Like, well, darn it. Now I need to use that in that module over there. Like, well, great. Now this has got to be shared between two different modules, and we didn't plan on that. Okay, now I got to create another module that's going to be shared between multiple modules. Right. But is that going to create a circular dependency? Is that going to create a problem? Or what about Dagger? And then you're like,
oh my God, yeah. Those are the exact caveats, right? Like essentially, like you can get complicated. And then if you have Dagger, Dagger in itself is slightly complicated to like comprehend. Actually, I'm not going to say slightly. It is pretty damn complicated to understand, right? Like you have to learn Dagger to be able to use it, which is like the biggest. It's just such a powerful tool that everyone like in the Android community uses it. But God damn, man. Oh, Dagger is just so, if only it was like simpler, right? It gets even more complicated when you have like different modules, because then what you'll have to do is you'll have to set up your dependencies correctly, which means then now with the Dagger 2 sort of terminology, you'll have to have like components in each of those and have dependencies between those components, exposing just the right modules within those components. Oh man, I just want to say
this. Is that I've been using Dagger and dependency injection for close to 13, 14 years now. I've been doing dependency injection. I started with Dagger 1, that was already difficult, as you said. Dagger 2 is a complete change of mind. I'm going to use politically correct words here. And then we come to Dagger like 2.1 or 12 or whatever it's on now. We have the Android component stuff, like even more. It's complicated. I think it's important to know for folks out there that are just getting into this and they think like, wow, everybody knows this. I don't know this. Don't feel that way.
Oh my God,
because
no. Yeah,
there's still times when I hop into a code base and it's full of Dagger stuff. I look at it, I'm like, I don't even know what's going on here. How is this working?
This is like because like we are in sharing mode here.
Yeah.
I'll let listeners know too. This is like one of those many blog posts I have in the making that I don't know when I'm gonna like get to actually writing. I have like these things, like these cheat sheets of like how to quickly understand Dagger, like visually, before I get into like a project if I'm messing with dependencies, because I don't know, maybe I'm just slow in the head, but I can never figure this thing out like, off the top of my hand. I always have to refresh my memory about how freaking Dagger works in the first place before going and making those changes, right?
Yeah, it's complicated.
Yeah, So if you're exploring modularization, be ready for a lot of that stuff because that is coming your way, especially if you use Dagger, right?
Definitely, yeah.
We touched on some of the other caveats, like, for example, the database stuff. Like with Room, I do know you need to have like independent databases. And for the longest time, I think there was some problem with using ButterKnife. You couldn't, if you used ButterKnife and Kotlin in like library modules, like you ran into some problem.
You end up having to use like a different resource identifier. So instead of r.id, you had to use r2.id, which has bit me more times than I can tell you, because it'll like, from what I can remember, it'll compile, it'll work, but it won't run. Yeah,
there was like some weird thing to it. I don't recall exactly what it was, like the specifics. What I do know though is this has been solved at the Kotlin layer. So if you're on Kotlin 1.2.20 or 2.0, I think this is no longer a problem. But not everyone's on the latest and greatest Kotlin version. So if you don't, you're going to run into this problem. So just keep that in mind. Mm-hmm. All right, Donn, I think this was a fun episode. We talked about modularization, Gradle dependencies, and I think secretly we got the topic that we really wanted to talk about, which is complaining about Dagger.
I think it's just complaining about just complexity, and I think the real point I'm trying to get across here is that, especially when I started out in software, I looked up to a lot of folks, and I thought like, wow, if I could know what they know, I'd be good. And I've been in the industry long enough now to know that I still keep looking up to folks, thinking that if I know what they know now, I'll be good. And the thing is, like, things are just complex. And even though that you're maybe starting out to learn them, realize that a lot of people are in the same boat as you. And just like you have this huge cheat sheet, I have the same thing inside of an Evernote document somewhere. I have to go look at how does X, Y, and Z work again, and why does it work that way? Oh, but if I have this weird edge case, then I have to do this other thing. That's completely normal. Now, that's all I'm trying to get across is like, you're not alone out there. Programming is hard. That's just the way that it is.
Programming is hard. On that happy note, Donn, if folks want to listen out or maybe, share their grief about how we can fix things with Dagger or other complex stuff in programming, what's a good way to reach you?
You can always find me on Twitter at Donn Felker, on Instagram at Donn Felker as well. And Kaushik, if folks want to talk to you about their trials and tribulations of going from monolithic to a modularized application. I said the word, yes. How can I reach you?
You've been really good with pronouncing that word. I've kept tripping, but you've been getting it 10 on 10. Good job. Well, if folks want to reach me, I am Kaushik Gopal on Twitter. And also with the same handle on Instagram and many other services. So feel free to reach out to me on Twitter. That's usually the best way. All right, folks, thank you so much for listening. We will catch you in the next episode.
Hey, I'm back. Let me ask you a question. Do you want to automatically build, test, and release your Android apps? If so, then you got to try App Center. You can connect your repo, and within minutes you can build in the cloud, test on thousands of real Android devices, distribute to beta testers, and monitor real-world usage with crash and analytics data. You know that sounds good, don't deny it. Spend less time managing your app lifecycle and more time coding. Now, if that doesn't get you excited, then you're listening to the wrong podcast, my friend. Visit appcenter.ms and get started for free. That's again, appcenter.ms. Thanks again, Microsoft.
That's it for the show, folks. Fragmented is hosted by Don Felker and me, Kaushik Gopal. We edit and produce all the episodes here on Fragmented. Sarah the Amazing Jackson from the Spec Network helps with production assistance and wraps our final mix. Our theme and ad music is by the national recording artist Blueprint from Weightless Recordings. You can find more Fragmented episodes at fragmentedpodcast.com. Thanks for listening, and we will catch you in the next episode.